Alright guys, I hope you are stoked to learn about Pythagorean theorem today because this is going to be one super awesome lesson. I know a lot of you guys already know the Pythagorean theorem, and I don't know what I was going to say. I'm sorry. So this is going to be a little bit of review. I know there's going to be some new stuff in this that I don't think you've seen before, but this is what we're doing. So Pythagorean theorem, what is the Pythagorean theorem? And then why do we use it? What are we going to use it for? Okay? So, first there's a little warm-up here, and it's on simplifying the radical, and this is what we did yesterday. So if you weren't here yesterday, here's a little tutorial on what we did. First hour, there is going to be a second video that you need to watch because there was some stuff that I missed on the simplifying radicals from yesterday. That I need to make sure you guys know how to do. It's the fraction ones. I did not cover that in first hour. And I didn't cover rationalizing the denominator either. So you need to watch the second video in order to complete your homework. If you complete the homework without watching the video, I'm going to know you use PhotoMath. So please make sure you watch the video. So simplifying a radical. So when we simplify a radical, what we're trying to do is we're trying to find a perfect square that will go into 75. So remember, our perfect squares are 1, 4, 9, 16, 25, 36, blah, 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 blah. So 75, right off the bat, I'm hoping you see that 25 is something that goes into 75. So we can rewrite this as 25 times 3. And then there was a rule that said, okay, if you can take 25 times 3, then what we can do is we can break this up into just the square root of 25 times the square root of 3. Well, I know what the square root of 25 is. It's a perfect square. It's 5. So this becomes 5 square roots of 3. So that's how you simplify the radical. So Pythagorean theorem. So Pythagorean theorem, the one thing everyone always tells me is a squared plus b squared equals c squared. What does that mean? A lot of people can tell me what Pythagorean theorem is, but they don't know what it means, what a squared is, what b squared is, and what c squared is. So the first thing you need to make sure you know is that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the sides. Okay? So remember, we have kind of already covered this a little bit. The hypotenuse is always the side opposite the 90 degree. Hypotenuse. I couldn't spell. It's always opposite the 90 degree angle. Okay? So that's always your C value. Okay? So when you're setting up a squared plus b squared equals c squared, the Pythagorean theorem says it's the square of the hypotenuse being equal to the sum of the other two sides. So it doesn't matter which one is A and which one is B, just as long as one of them is A and one of them is B. But C has to be your longest side. And then it's just a squared plus b squared equals c squared. So our central question is, what is the Pythagorean theorem? Well, it's a squared plus b squared equals c squared. What is it used for? It is used to solve or to find a missing side in a right triangle. And I emphasize right triangle because if it's not a right triangle, we're going to have to use alternate methods. And that's what's going to be our next couple day lessons. Okay? So in the first example, it says find the value of x. So the first thing you have to decide is what is C. Because it doesn't matter what A and B are, but C has to be the one that's on its own side of the equation. And C is always opposite the 90 degree. So in this case, X is my C. And then I don't care which one's A and which one's B. So I'm just going to write A and B on the other ones. So when I set up my equation, a squared plus b squared equals c squared. If A is 5, I have 5 squared. And B is 12, I have 12 squared. This should equal c squared. Okay? So this kind of looks like the equations I did with you yesterday on that solving equations sheet. 5 squared is 25, so when you get to this point, you're going to want to go ahead and square these. 12 squared is 144, and then it equals c squared. I'm going to add 25 and 144. So that gives me c squared I'm sorry. I forgot to substitute in x for c. That was my bad. So this should be x squared and then x squared. So we have x squared equals, well, 25 plus 144, that's 169. Remember, once you get to the point where x is by itself and it's squared, to get rid of the square, we square root both sides. Square roots and squareds are opposite operations. So square root both sides. Type in the square root of 169 into your calculator, and that gives you 13. So x is 13. So we use the Pythagorean theorem to find the missing side length in a right triangle. Okay, example 2 is a little trickier, but not a lot. It says find the value of x. So again, the only one you have to worry about is c. So opposite the 90-degree angle, c is our 14. So when we set this up, it doesn't matter which one A is, it doesn't matter which one B is, but it does matter that 14 has to be the one by its own side. So I have 7 squared plus, so A squared plus B squared. B squared is x squared equals c squared. Well, c squared is 14 squared. And this is where a lot of kids would have made a mistake, because they would have set it up just like I did in the top, and they would have had 7 squared plus 14 squared equals c squared. And that is not going to get you the correct answer, because in that equation, you're telling me that c is your hypotenuse, and that your hypotenuse would be this side right here, and that's not true. That's not your hypotenuse. So make sure you set them up correctly. Once they're set up, then all you have to do is go in and actually square them. So we get 49 plus x squared equals 196. Again, put these in your calculator. 14 squared goes in your calculator. Subtract 49 from both sides, so that gives me x squared equals 147. You're going to square root both sides, so that gives you x equals, well, 147. I'm looking for a perfect square that goes into 147. Well, 49 and 3 will give you 147. You take the square root of 49, you get 7 square roots of 3. Again, I told you guys at the end of the hour, your calculator will do those things for you. Since we spent a day doing them by hand, you do not need to do them by hand today. You can just type them in your calculator and see what the simplified version is going to be. Okay, so the converse to the Pythagorean theorem. A converse is just a flipped version of something. So the Pythagorean theorem said if you have a right triangle, then a squared plus b squared equals c squared. So in the Pythagorean theorem, you have to know that you have a right triangle. If you don't have a right triangle, you can't use a squared plus b squared equals c squared. So what the converse says, it says, okay, you've got this rando triangle. So if the sum of the sides, or if the length, I'm sorry, I missed a word when I typed this. So it should say if the square of the length of the longest side in a triangle is equal to the sum of the squares of the lengths of the other two sides, then it has to be a right triangle. So the difference is, in this one we're saying, okay, if a squared plus b squared equals c squared, then we get a right triangle. It's got to be a right triangle, because that only holds in a right triangle. So here, we don't know this triangle is right. If we go through and we solve it, and in fact, a squared plus b squared, that value does in fact equal c squared, then we have to have a right triangle. Okay? So you don't know that you have a right triangle to begin with. So it says, tell whether each one is a right triangle. So in A, you've got 8, square root of 113, and 7. So the one thing I told you have to worry about in these is that C has to be the longest side. So when I'm setting this up, my longest side has to be by itself. In order to know which one is my longest side, pictures are liars, so don't always go off of what a picture says. Type in the square root of 113 and see what the decimal is. it's about 10.6. So since I know that that's bigger than 7 or 8, this has to be C. So these are A and B. So now we're going to set up A squared plus B squared. So 7 squared plus 8 squared. We want to know, does it equal 10.6 squared? We don't know if it equals. So we're going to put a little question mark over it. So what that gives me is 49 plus 64 equals 10.2 squared, 104.4. Oh, I'm sorry. I messed up. This is my bad. Go back over here. We're not going to put 10.6. 10.6 is an approximation. We're going to type in the square root of 113 squared. Well, square roots and square roots cancel, so you get 113. And 49 plus 64 does, in fact, equal 113. So this is a right triangle. Okay? So the second one is the same type of problem. I'm going to let you try that one on your own. You do need to try it on your own. I know you're probably thinking right now, I'm going to skip this. I'm not going to actually do this problem. She's not here. She doesn't know. Because when you turn these notes in, I am going to specifically look at this problem and see if you attempted the work, okay? So when you try B, actually, you know what? We're just going to go and do it. Never mind. Ignore me. So when I set this up, I have to know what C is. Well, if you type in 4 square roots of 95, it ends up being bigger than 36 and 15. So this one has to be C, this one's A, and this one is B. So we're going to do 36 squared plus 15 squared. And we want to know, is that going to be equal to 4 square roots of 95 squared? Well, 36 squared, that's 1,296. 15 squared is 225. And that adds together to give you 1,521. 4 square roots of 95 squared is 16 times 95, because the square root of 95 and the square are going to cancel, and then 4 squared is 16. And that gives you 1,520. And see, those are not equal, so this is not a right triangle. Not a right triangle. Okay, got 2 more examples. We're almost done here. Triangle inequality theorem. The triangle inequality theorem is actually from chapter 6, and we skipped over chapter 6. We're not doing it. But the triangle inequality theorem says that if I pick any 2 sides in a triangle, in order for it to make a triangle, any 2 sides have to add together to be bigger than the third side. So if I give you a triangle of like 2, 5, and 3, if I take any combination of those 3, 2 plus 3, that has to be bigger than 5. 3 plus 5, that has to be bigger than 2. 5 plus 2, that has to be bigger than 5. Any of the combinations. Pick any 2 sides, they have to be bigger than the third side. We'll see how 2 plus 3 was not bigger than 5. It's equal to 5, but it's not bigger than. If my side lengths were 2, 3, and 5, that does not actually form a triangle. In order for it to form a triangle, all 3 of these inequalities have to hold. You have to pick any 2 sides, add them together, and it's got to be bigger than your third side. Okay? So we have this example that says, if a triangle has sides of 2, 9, and 14, does that actually give me a triangle? Does it form a triangle? So if it is going to form a triangle, then I've got to test these 3 inequalities. So I'm going to take the 2 plus the 9. That has to be bigger than 14. 9 plus 14 has to be bigger than 2. So I did these 2 has to be bigger than the last one. These 2 has to be bigger than the first one. And then 2 plus 14, that has to be bigger than 9. Well, 2 plus 9, that's 11. See, 11 is not bigger than 14. So it doesn't even matter if these 2 hold, because since this one didn't, this is not a triangle. It's not going to form a triangle even at all. So it doesn't matter if it's an acute triangle, an obtuse triangle, or a right triangle. It's not even a triangle. It's going to look something like that. There's going to be like a giant gap because the angles aren't going to work out nicely. Okay? So all 3 inequalities have to hold in order for it to form a triangle. So then we're going to take that a step further, and we're going to say, okay, if, when you work this out, we've decided that if a squared plus b squared equals c squared, that means you have a right triangle. That's what the Pythagorean theorem says. Okay? So what happens if a squared plus b squared doesn't equal c squared? Then what triangle do you have? Well, if a squared, and I'm going to rewrite these because I don't like c by itself. So if a squared plus b squared is greater than c squared, then it's a acute triangle. And if a squared plus b squared is less than c squared, then it's an obtuse triangle. Okay? If a squared plus b squared is greater than c squared, it's an acute. If a squared plus b squared is less than c squared, it's obtuse. And if they're equal, it's a right triangle. So example 5 says, verify that this length 4.3, 5.2, and 6.1 even form a triangle. And then if it does form a triangle, is it going to be acute, right, or obtuse? So I have to do the 3 things from the last example. So I have to know, okay, if I take 4.3 plus 5.2, that has to be bigger than 6.1. If I take 5.2 plus 6.1, that has to be bigger than 4.3. And if I take 4.3 plus 6.1, that has to be bigger than 5.2. So this one here gives me 9.5. Well, that is bigger than 6.1. This one gives me 11.3. That's bigger than 4.3. And this one gives me 10.4. That is bigger than 5.2. So it is a triangle. Now, is it obtuse, acute, or right? That's what we need to decide. So we're going to take a squared and b squared, and we're going to compare it to c squared. Remember, c is your longest length. So c has to be the 6.1. And then it doesn't matter which one is your a and your b at that point. So I'm going to do 4.3 squared plus 5.2 squared. And I'm going to compare that to 6.1 squared. I'm not going to put an equal sign or an inequality in there because I don't know what goes there right now. So if I type that in my calculator, well, 4.2 squared, or it's 4.3, my bad. 4.3 squared is 18.49. And 5.2 squared is 27.04. And 6.1 squared is 37.21. So then I have to go over here and I have to add these two together. So 18.69, or 49, I think that was a 4. Sorry. 18.49 plus 27.04. That gives me 45.53, and that is bigger than 37.21. So what we found was a squared plus b squared is bigger than c squared. So if I go to the top here and I go back here, it says, okay, well, if a squared plus b squared is bigger than c squared, that is in an acute triangle. So these are going to form an acute triangle. Okay, so that's all I have for you. At this time, you need to show that you have completed the notes to the sub. She will then hand you a blue sheet, which is the Pythagorean theorem homework. I think it has like 14 problems on it, maybe 15. And then she's going to hand you a white sheet. I did the first example on the white I did the first problem on the board for you. All you're doing is simplifying radicals. Yes, you do need to show work. No, you cannot just simply plug them into a calculator. So what you're going to do is you're going to work them out, and it's going to have like little thick colors to the side. One of them is the correct answer. Whatever the correct answer is, that's going to give you a color, and you're going to color all of that number that color. So for example, the first one's like the square root of 50-something, 7, I think, 57. And when you do it, it gives you the first one, which is red. So all the ones on the back side, you're going to color red. The coloring portion is extra credit. However, if you are sitting around doing absolutely nothing, that is a poor use of your time. So you might want to earn some extra credit. Some of you, based off of your quiz scores, could probably use some extra credit. So maybe consider doing it. Due dates for all your stuff is on the board. The assignment that we did on Tuesday, that is due on Friday. So the Simplifying Radicals is due Friday. And then the 2 other assignments that I'm giving you today, those are due on Monday. I'll be back Friday if you have any questions on any of this, and I hope you guys have a great day.